on solving one-step multiplication equations. First task we need you to do, we have 4 review ones. Determine the unknown product or factor that makes each statement true. In other words, solve each of these 4. If it helps you, you can put an X in the blank initially, but most of these should be pretty straightforward. So we'll give you guys about 2 minutes. Go ahead and go. Okay, our first one. The rule for multiplying fractions is just multiplying. Top times top. 4 times 5 is 20. Bottom times bottom. 5 times 4 is 20. 20 over 20 is 1. What number would I multiply 5 by to get to 1? Gavin? 1/5. So I end up with that same deal. 5 over 5 is 5. 1 times 5 is 5. 5 over 5 equals 1. 3. Who was able to figure this one out? Adam? Good. 7 over 23. This is where I'm going to go the way I prefer to do it. I have 23 is top and bottom. Those cancel. 7 is top and bottom. Those cancel. 1 over 1 equals 1. This one again. Now here is the tricky question to see who actually has some vocabulary recall. You may notice that every one of these problems, when I multiply a number by another number, I got 1. What do we call that relationship? How would we describe 5/4 and 4/5? What do we call them? They have a special name because when I multiply them, they equal 1. What is the math vocabulary for that? Nobody? I honestly thought of all my classes, we'd get at least 2 people in this class that would have the answer. What is the math vocabulary term for 2 numbers that I get a product of 1 when I multiply them? Mason?
I thought I had it and then I skipped away. I'm going to guess equal lateral.
No.
No, wait.
Okay, apparently we need this again, so write this one down.
Multiplication, inverse operation.
We had 2 terms we used, either multiplicative inverse or reciprocal. Both of those mean a number multiplied by another number that equals 1. So the reciprocal of 5 is 1/5. The reciprocal of 23/7 is 7/23. The multiplicative inverse of 4/5 is 5/4. I can use those 2 terms interchangeably. Just make sure you understand that, okay? Hope you guys wrote that down so you won't forget it again. Guys, please quiet. Now we're going to do 3 equivalent equations off of this double number line. So this is just like last class. The only difference is we're now using multiplication instead of addition and subtraction. So see if you can use what we've given you on the double number line to write the 3 equations, then find the value of n that makes all of them true, and then tell me how can I check that value in my equations. So we'll give you guys about 3 minutes. You got 3 equations to write. Hey guys, real quick review. Guys, quick review. If I write a number 7 beside a variable, what operation is that? Multiplication. So that's saying multiplying. Okay? So that gives you a hint on how you'll be able to figure out what n is. Starting. Okay, remember, when I have this barbell on my double number line, that's telling you that the 2 parts are equal, right? So if I want to turn that into equation, I can just make that an equal sign. So I say 2n equals 6. 4n equals 12. 7n equals 21. Did I write all the equations? Did we get all three? Yes. Now I need to know what value of n is going to make all of them true. Who was able to figure that one out? Kingston? Good. N equals 3. Makes them true. How do we check? Christopher? Good. All I have to do is I take my equation, and where my variable is, I substitute the value that I found for it. What's 2 times 3? Does 6 equal 6? There's our check. Did it say I had to check all three of them?
No.
If I showed it once, do you think that's adequate?
Yeah.
Yes. Technically, if I do it twice, I prove that it will always work. But as long as I've got one check, we've done what was asked. Questions on this page? Okay, let's go to our next page. We're on 425. On this one, we're actually going to walk through this all together to make sure everybody is on the same page. So just as with our addition equations, solving multiplication equations involves determining the value for the variable that makes this statement true. That's what we're trying to do. So if I look at the multiplication equation 2x equals 6, this equation states that for some value of x, the expression 2x is equal to 6. So when you're setting up your double number line, one question you need to ask yourself is that 2x going to be further or closer to 0 than x? 2x is closer to the 0 than x is? So x is closer, right? So should I put the 2x further away or closer to 0? Further away, because I know x is going to be less. So I can now decompose the distance of 2x into 2 equal parts to determine the location of x. The expression 1x or x is halfway between 0 and 2x. Is everybody okay with that? So if I have 0 here and I have 2 x's there, x is going to be directly in between the two of them. Now, knowing that, on the bottom line, remember the bottom is equivalent, correct? So on the bottom, I started at 0 and I went to 6. What's going to be halfway between those? Because? Good, because 6 divided by 3 is 2. Which now gives us our solution, because remember that barbell between them could be replaced as an equal sign. So we can now see that x equals 3. Does this make sense for you guys?
Yes.
Okay. I hope so, because we're going to give you a chance to prove it. We want you to use the double number line to decompose the distance of the variable into equal parts to determine the location of x. Identify and check your solution. There's one of your big keys. I have to break it into equal parts. So if I have 3 x's, how many parts do I need to break it into? 3. If I have 7 x's, how many do I need to break it into? 7. Make sense? Okay. We'll give you guys about 4 minutes to do this, because you also need to check your solution.
All right, so our first one says 3x equals 12. So what am I going to do to this number line to find out how much x is worth?
You would divide by 3.
I'm going to separate it into 3 parts, because that is my whole number. So I have 1x, 2x. What does 1x equal? 4. So if 1x is 4 and 3x is 12, what is 2x? So I have 3x equals 12. We're saying x equals 4. So does 3 times 4 equal 12?
Yes.
Then we are correct. Any questions? All right, so what am I going to do to the number line on number 2? I'm going to separate it into how many pieces? 7. So that's x, 2x, 3x, 4x, 5x, and 6x. So what does 1x equal? 9. And if I continued, it would count by 9s. So they gave us 7x equals 63. If x equals 9, does 7 times 9 equal 63?
Yes.
Okay, so I separated my number lines. What operation in math does that model? Separating it into pieces.
Distributed property.
What operation, not what property? Division, and that is what you're going to use to solve multiplication equations. So let's look at the next page.
What you're going to notice on this one is we're no longer going to be dealing with strictly whole numbers. So multiplication equations often include numbers other than whole numbers. So if I look at an equation like 1/3 x equals 2, how is that variable term in this equation different than what we saw in the previous activities? I'll start with what term is with my variable. X is my variable. What term is with it? 1/3. How's that different than what we've been seeing before? It's a fraction. What were the other ones? Okay? So there's our big difference. We were using whole numbers. This time, it is a fraction. Which, go ahead and pull out your highlighters real quick, or marking pens, because this is actually a critical concept for today, and making sure you guys understand that this is actually the same thing. If I have 1/3 x, that is actually the same as just saying x divided by 3. So when I multiply it by a fraction, it's the same as dividing it. And when my numerator on the fraction is 1, it's the same as dividing it by the denominator. Okay? So key concept, make sure you're understanding and comfortable with that. Now, we're going to consider the multiplication equation, 1/3 x equals 2, the example we started with. This equation states that for some value of x, the expression 1/3 x is equal to 2. So now if I'm looking at 1/3 x, is x going to be further to the right or further to the left of 0 than that? Further right, right? Because now I'm only looking at a part of x, meaning my actual x is going to be further to the right, meaning my initial equation, I need to start a little further to the left, because in order to solve, I'm going to be going further right. Does that make sense for everybody? Okay? That's just going to help you set the equations up. One way to solve the equation for x is to compose 3 distances equal to 1/3 x to create the distance of x. Then, to maintain equivalence, compose 3 distances equal to 2. So what we've been doing on these double number lines is we're saying, okay, well, if I have 0, then I have 1/3 x. My next interval is going to be 2/3 of x, correct? Because I've added another third, meaning my next one is going to be x, because 3/3 of x, 3/3 is the same as what, Vincenzo? Wow, way to throw your voice, Vincenzo. That sounded just like Kingston. Christopher? Yeah, okay. But on the bottom, my interval's a little different, right? The first interval went from 0 to 2, so my next box would be 4. My next box would be 6. Is there anyone who doesn't see that? Because if you can understand this, then the double number lines will help you make sense of what's happening. But everybody's good with that? Okay. So complete the worked example by filling in the unknown values. We already did that. Then write the solution to the equation 1/3 x equals 2. So where is our solution on our double number line? Raise your hand once you see where the solution is. I'll give you a hint. It's up there. Our solution is on the double number line. Raise your hand when you see it. Only about a fourth of the hands are up. This isn't good. We've done all the work, guys. Your solution is right there staring you in the face. No, this isn't good. We're still less than half. Guys, my solution happens when I know what x is, right? Do I know what x is?
Yes.
Just like we did in the last exercise. I can replace my barbell with an equal sign, can't I? So I can say x equals 6. Isn't that what's below the x? Remember, the barbell tells me where it's equal. How do I check my solution? Cloud, I haven't called on you yet. Good. So I go back to my original equation, 1/3 x equals 2. But now I know what x is, so I'm going to say 1/3 times 6 equals 2. Yes, I did that intentionally, so I can put it over 1. 1 times 6 is 6. 3 times 1 is 3. 6 over 3, I can simplify it to 2. 2 equals 2. Check. So we have our solution, x equals 6. Does everybody understand how to check your solution? So I'm seeing a lot of questions on that so far today. You're literally just substituting the value back into your equation, making sure that the two sides are actually equal. You guys understand that when I had 1/3 x, I needed to get into 2 more intervals to be able to get to x, right? I'll give you guys a big hint right now. The bottom part is telling me how many intervals I need. That's how many lines I should have on my double number line. Okay, let's turn the page and go to our next one. Because now is your chance to practice. Okay, so I want you guys to do 3 and 4. Take a look at the number that is with your variable. That's going to give you an idea of how many intervals you need. Then identify and check the solution. Okay, so it's kind of the same thing. Compose the distance into appropriate equal parts to find where x is. So we'll give you guys about 4 minutes. Go ahead and we're almost done. Okay, guys, this one, the key is 1/4 x is going to be closer to 0 than x is. So I'm going to do my initial interval here, 1/4 x and 7 with my barbell between. So that means my next one is going to be 2/4 x or 1/2. My next interval is going to be at 3/4 x. And then 4/4 x or x will be the last interval. But I'm going up by 7s on the bottom. So that gives me 7, 14, 21, 28. Meaning I've now reached my solution. X equals 28. And we do our check. So I put it back into my initial equation. 1/4 x equals 7. 1/4 times 28 equals 7. Put 28 over 1. 4 goes into 28 7 times. 1 times 7 is 7. 7 over 1 is 7. 7 equals 7. Check. Our next one. This one should be really easy because it's just 1/2 x. So I've only got the 1/2 x and 5. There's my equation. Meaning the next one is 2/2 or x is 10. There's my solution. X equals 10. Putting it back into my initial equation. We started 1/2 x equals 5. But I now know it's 1/2 times 10 equals 5. Goes 1 and 5. 5 over 1 is 5. 5 equals 5. Check. Questions? It should be relatively easy, and we'll make it even easier for you before the end of the day. Okay, Vanessa was given a harder problem. Hers says that 4/7 x equals 12. So she needed to start breaking this down on her double number line. Notice, what is the number with my variable now? Yes, ma'am.
Their problem is different.
Yeah, change yours to this. Your double number line is the same. I don't know why they changed it. So the big difference on this one, guys, coming back from lunch, so if I repeat myself on YouTube, I apologize, is the coefficient with my variable, the number that's with it. It is now 4/7. We've been dealing with ones of everything so far. So here's Vanessa's thinking. She says, I created my double number line and represented the equation and x. Then I labeled the bottom number line to identify the value of x. So let's look at how she did it, because this is going to be really critical for you guys in order to use these double number lines. She said my value was 4/7, correct? So how many intervals did she need to get to x? 7. Does everybody see that? Anybody not see it? Okay, so she created 7 intervals. 1/7, 2/7, 3/7, 4/7. This is interesting. 1, 2, 3, 4, 5, 6, 7, 8.
You started
No, I did it right. They have one too many on their line. They do. So we'll cross that one out because it shouldn't be there. 5/7, 6/7, and then 8/7, which is where x was. But at 4/7, what was the value according to my equation? 12. Now remember, below every interval, I have another interval on my other number line, correct? Oh, that's why, because that started at 0.
Yeah, I was trying to tell you that.
Thank you. I appreciate that, Kingston. Whew. That had me worried for a second there that they messed up again. Okay. Knowing that I started at 0, I now have how many intervals to get to 12? 4. Because this one is at the 4th interval, correct? So what would the value be for each of those 4 intervals? At the 4th interval, it's 12. So what would I go up by 4 times to get to 12? 3. Meaning each interval along the way is 3. 3, 6, 9, 12. So that now verifies, right? We did it right. Then it's going to go 15, 18, 21. Does that make sense for everyone? Jedediah? No. Okay. So after she did it in 2 steps, we just kind of did it in 1. So all she's saying is on the next step, she did this. Why did she set it up this way? What do you think?
Because it's divided by 7 parts.
Good. The denominator told me I needed 7 parts. And what did the numerator tell me? Triton? You can do it. Really, Triton? Why did she know it went on the 4th interval? I know, it's a really deep question. Ooh. What's my numerator? Huh? You don't know? The numerator of 4 told me where the equation was located. So that basically gave me my starting point. You don't see that yet, Triton? You do? Good. Okay. So identify and check her solution. What was her solution? Hope you guys are getting used to this. Where the variable is by itself, that is my solution. So her solution was x equals 21. But to check it, we go back to our original equation. 4/7 x equals 12, correct? But now instead of x, I now know that x is 21, so let's check that. 4 sevens times 21 over 1 equals 12. I have one reduction I can do. I can divide by 7, gives me 4 and a 3. 4 times 3 is 12. 1 times 1 is 1, so that's 12 over 1. 12 equals 12. Did her solution check? Yes. When you do the math, given what she found for her value of x, it solved the equation. Questions on what we've done on this page, because this is actually relatively complex. So the big keys, look at the denominator, that tells you how many spaces I made. Look at the numerator, that tells me where along those spaces I'm located. So if my numerator is bigger than my denominator, what does that mean? It's an improper fraction. Is x going to be closer to 0 or further away from where my equation is if I have an improper fraction? Well, engage it, Olivia. Emery? It's going to be closer. Because think of it this way. If I had said this was 9 sevenths x, where would it be? X would be here. I'd still need to go 2 more to get to it, right? 8 sevenths, 9 sevenths. Does that make sense? Okay. I hope so, because you're going to get a chance to show us. So you have 3 more to do. You have to do the double number line. You have to plot it to solve it, and you need to check your solution. So I'll give you guys about 5 minutes to do these 3 equations. Go. So again, if we look at it, my denominator tells me how many intervals I need. So I need 5 intervals. 1, 2, 3, 4, 5. Because I have 1/5 x, 2/5 x, 3/5 x, 4/5 x, and then 5/5 x, or x itself. On the bottom, I match all of those intervals, because remember our barbells go straight across. The equation they gave me was at the 4/5, meaning right here, I know that my answer is 12. So I now have my first barbell set up so that I can do what I need to, which is get to my answer. I now look, I have 1, 2, 3, 4 intervals to get to 12. So how much is each interval? 3. 3, 6, 9, 12. So that actually verifies. Meaning I now get to my solution of x equals 15. However, we were also supposed to check our solution. Meaning I start with my equation, 4/5 x equals 12. I now substitute my solution in times 15 equals 12. 15 over 1 gives me 1 and a 3. 4 times 3 is 12 over 1. 12 equals 12. Our solution checked. We're good. Does that make sense for you guys? Let's try it again. How many intervals do I need? 4. 1, 2, 3, 4. So I have 1/4 x, 2/4 x, or 1/2, 3/4 x, and x. I have 4 intervals below it. My equation is 3/4 x is 8. So I can fill that one in. I now have 1, 2, 3 intervals to get to 8. So what is each interval? Divide 8 by 3, what do you get? 3 will go into 8 how many times? 2 with how much left over? 2. So it is 2 and 2/3. 2 and 2/3, I double that, gives me 5 and 1/3. Then I get 8, then I get 10 and 2/3. So there's my solution. X equals 10 and 2/3. We need to check it, so we go back to our original equation. 3/4 x equals 8, but I now put in 10 and 2/3. How do I multiply a fraction and a mixed number? Alyssa? Awesome. Slam dunk. We need a improper fraction. Gives us 3/4 times 30 plus 2 is 32 thirds. 3's go away. 4 goes into 32 8 times. 8 over 1 equals 8. Did our solution actually check? Yes, it did. So x was 10 2/3. Our last one, 8/5. So what's my intervals? 5s. So I need 1, 2, 3, 4, 5. So that's 1/5 x, 2/5 x, 3/5 x, 4/5 x, x. How many intervals do I need? 8. So I have to keep going, don't I? So now it becomes 6/5 x, 7/5 x, 8/5 x. Why? To make it dramatic and point out that I needed to go past my n number. Each one of these has an interval below it. Our equation tells us that at 8/5 x it is 64. How many intervals do I have? 1, 2, 3, 4, 5, 6, 7, 8. So what does that make each interval if it takes 8 to get to 64? 8. So we can check it. 8, 16, 24, 30, 30. Thank you, 32. I started going by 6 for some reason. That's why I paused, because I was like, wait, something's not working. 40, 48, 56, 64. So that actually worked. So now that we've done that, we can now see that, what does x equal? 40. There's our solution. Let's check it. 8/5 x equals 64. 8/5 times 40 equals 64. 5 and 1, I can divide both those by 5. It gives me 8 and 1. 8 times 8 is 64. 64 equals 64. We checked. Yes, sir.
On this thing, if you turned 8, 5 over 5 into 5 over 8 into 5 over 64, then you still get 40.
Okay, so here is where I'm going next. Is basically what Christopher just said. Instead of using the double number line, it will go much more quickly if we get back to the way we taught you to do it last class. So if I have 8/5 x equals 64, what was the process? Circle my variable, draw a line through the equal sign. What number is with my variable? 8/5. What's the operation? Multiplication. So the opposite would be division. So I divide by 8/5. But remember, when we divide fractions, we actually multiply by the reciprocal, right? So instead of dividing by 8/5, I can multiply by 5/8. Multiplicative property of equality, though, says if I do it to one side, I must do it to the other side, correct? So now these all go away, those all become 1s. On this side, 8 goes into 64 8 times. 8 times 5 is 40. Did we get the same answer? Did I have to do the double number line and all the intervals and everything else? No. So you can go far quicker if you just solve it. Let's go to our homework. Yeah, we got to hand back test too.
I'll get that for you back.
Okay. Guys, quiet, because we also got to get your test back. Homework. Guys, seriously. Use the double number line to solve and check. So I need a check in there as well.
I think he's
Lucas. Second page. Solve. Do I have to use double number lines? No.
Guys, quit talking.
I'm about to give you a huge tip. Here's my variable. The opposite of 3/8 is I'm multiplying 8/3 is I'm multiplying by 3/8. So if you'll do that every time, these are all going to go away. So you have your variable by itself. This means it's being divided by 3. So if I just multiply both sides by 3, that gives me my answer. If I'm doing the decimals, sorry, you're going to have to do decimal division.
Quit talking.
Okay? Same thing on this one. The opposite of 2/9 is 9 halves.
Mr. Moore, pause for just a second. Mr. Moorside, we did not tell you to pack. Sit down. The only one that should be moving is the one that I told you to go to the nurse. Everybody else needs to stop.
Okay, then you have 2 additional questions you'll have to work out. Good luck, guys.